Welcome to the Walton Pi. Today we're going to be discussing differential equations and one method to be able to solve them. And that method is going to be integrating factors. So what even is it? Well, the method of integrating factors is one technique to solve certain types of differential equations. I'm going to be discussing how we can use this to solve certain types of first-order differential equations, and it can even be used to solve certain non-separable differential equations. So this is going to give us a way of being able to approach first-order differential equations and have a way of being able to solve them. And the name integrating factors also gives us a hint at the big idea of the method. We're going to have some factor that we're going to multiply the entire differential equation by, and that's then going to allow us to more easily integrate the differential equation to get to an answer. So let's go through an example and we're going to illustrate this process. So suppose that we are given the following differential equation. Y prime plus 2xy equals 2x cubed. The idea of an integrating factor is we are going to multiply everything by some integrating factor mu. Once we've done that, we're then going to solve for what value or function of mu is going to turn the left-hand side into an expansion of the product rule. So, what value of mu makes mu times y prime plus 2 mu xy equal 2 mu x cubed have the left side be a product rule. So we have our differential equation and what it has turned into, and the product rule on a function f times g, the derivative of that is going to be f times g prime plus f prime times g. So one of those functions, f or g, we're going to want to call y. So let's just say that we're going to say that g is y. And so we have our mu y prime plus 2 mu x times y. So if g is y, then f is going to be mu from that first part, mu y prime. That's going to match up with f times g prime. So how do we then solve for f? Well, we know f is mu, and then f prime is going to have to be that 2 mu times x. So that means if we replace mu with f, we get f prime equals 2xf. Now hopefully you've seen this type of differential equation before. It's a separable differential equation, and when we solve it, we find that f is going to be e to the x squared times some constant. So now that we have f, we're just going to pick one of those, so might as well pick the one that's e to the x squared times 1, and so that means mu is going to be e to the x squared. So that means if we multiply everything by e to the x squared, then the left side is going to become fairly easy to integrate. And the right side, well, we'll see. The right side can sometimes become a bit of a beast with these types of problems, so we'll deal with that in a second. But once we've multiplied everything by e to the x squared, we now have e to the x squared times y prime, that's equal to e to the x squared y prime plus 2x e to the x squared y, which is equal to our right-hand side, 2 e to the x squared times x cubed. So if we integrate both sides, the left-hand side just becomes e to the x squared times y, but the right-hand side is then going to be the integral of 2x cubed e to the x squared dx, which we somehow have to find a way to integrate. Well, we can rewrite this a little bit to be x squared times e to the x squared times 2x dx, and then here, a u substitution where u equals x squared turns this into the integral of u e to the u du, and then this is just an integration by parts problem. So that becomes u e to the u minus e to the u plus some constant c, which then if we replace u equals x squared again, we get x squared e to the x squared minus e to the x squared plus c, which means that e to the x squared y is equal to x squared e to the x squared minus e to the x squared plus c, and if we then divide everything by e to the x squared, we get y equals x squared minus 1 plus some constant divided by e to the x squared. And that is our solution to this differential equation. Okay, so now that we have an idea as to how we can use integrating factors and how they're useful, is there a faster way to find the integrating factor than going through that whole process and going through that and trying to figure out all those different pieces? Well, it turns out that there is, and so I'm so happy that you asked me. So it turns out that there's a straightforward algorithm/shortcut to be able to find the necessary integrating factor. If our differential equation is in standard form, which means it's y prime plus some function times y equals some function, then our integrating factor is mu is equal to e to the integral of p of x dx. So in our last example, p of x was 2x, and our integrating factor was e to the integral of 2x, or e to the x squared, which is where this formula is coming from. Okay, so now that we've covered the entire process, let's review it one more time real quick so we can see the outline of the method of integrating factors. First, put the differential equation into standard form. Y prime plus p of x times y equals q of x, where p of x and q of x are whatever functions you need in order for that to work. Second, you can use the formula mu is equal to e to the integral of p of x dx to find the integrating factor mu. Third, multiply everything by that integrating factor mu, both the left-hand side and the right-hand side. You need to multiply both sides. Fourth, integrate both sides to get mu y on the left, and then the right-hand side, you're going to just have to figure out how to integrate. That can be a bit tricky, but brush up on some of your calculus and some of your integrating techniques, and you should be able to figure those out. And fifth, once you're at that point and you've integrated both sides and you have functions on both sides, divide both sides by mu to then solve for y. And once you've done that, you've finished. You've completed this problem. And that is going to be the method of integrating factors. I hope this video was helpful. If it was, please consider giving it a like and subscribing. It really helps me to be able to keep making these videos and to be able to know what types of videos I should make. So if there's any type of differential equation problem or any other question from math that you would like to have me make some videos on, please leave it in the comment section down below. Have a great day and good luck with the rest of your math.